STP blocks every redundant link in your network. You add more cables, and your network still runs on a single path. EtherChannel changes that. It bundles multiple physical links into one logical link, so all of them stay active without creating loops. Imagine two switches connected by 4 gigabit links. Without EtherChannel, STP blocks 3 of them, leaving just one active link. With EtherChannel, all 4 links combine into a single logical interface called a port channel. STP sees one link instead of 4, so no loops form, and you get the full bandwidth of all links working together. Broadcast frames received on one member port are not flooded back out of the other member ports in the same EtherChannel. This prevents loops while keeping all links active. EtherChannel does not completely replace STP. In larger networks with multiple switches, STP still blocks some EtherChannels to prevent loops. But with EtherChannel, you get more active links than without it. When STP shows the spanning tree, it displays the logical port channel interface instead of the individual physical ports. The combined bandwidth also affects the STP cost calculation. There are 2 ways to configure EtherChannel: dynamic and static. Dynamic uses a protocol to negotiate the EtherChannel, which is the recommended approach. Cisco's PAGP uses 2 modes: desirable and auto. Desirable actively tries to form an EtherChannel. Auto responds to a desirable neighbor but does not initiate. Desirable plus desirable forms an EtherChannel. Desirable plus auto also works, but auto plus auto does not. Neither side initiates, so no EtherChannel forms. You configure PAGP with the channel group command on each member port. The group number identifies the EtherChannel locally. After assigning ports, a logical port channel interface is automatically created. Configure trunk mode on the port channel interface, and the member ports inherit that setting automatically. You can also configure on the member ports, and the port channel inherits. But it is best practice to configure on the port channel interface to ensure consistency. Use Show EtherChannel Summary to check status. The S flag means Layer 2, U means up and in use, and P means bundled in the port channel. Use Show Pegged Neighbor to see neighbor details. LACP is the IEEE standard alternative to PAGP. It works on any vendor's switches, not just Cisco. This is critical for the CCNA exam. If a question mentions a non-Cisco switch, you must use LACP. LACP uses active and passive modes, which are equivalent to PAGP's desirable and auto. Active plus active works. Active plus passive works. Passive plus passive does not. LACP supports up to 16 links in a single EtherChannel, compared to PAGP's 8. But only 8 can be active at once. The rest are standby links. The configuration is identical to PAGP, just with active and passive instead of desirable and auto. Use Show LACU Neighbor to verify LACP neighbors. Static EtherChannel uses Mode On, with no negotiation protocol. Both sides must be configured with Mode On. If one side uses a protocol and the other uses on mode, the EtherChannel will not form. Static EtherChannel is risky because there is no negotiation to verify the configuration matches. Mismatched settings can cause Layer 2 loops. Use PAGP or LACP unless you have a specific reason to use static, like connecting to a wireless LAN controller. All member ports in an EtherChannel must have matching settings: speed, duplex, operational mode, allowed VLANs, native VLAN, and access VLAN must all match. If a port's settings do not match, it is placed in a suspended state and cannot forward frames until the settings are corrected. The simplest rule is to configure all member ports identically. EtherChannel load balances by flow, a communication between 2 nodes. All frames in the same flow use the same physical link. This preserves frame order within each flow. You can configure which parameters identify flows with the port channel load balance command. Options include source MAC, destination MAC, source and destination MAC, source IP, destination IP, and source and destination IP. The default on most switches is source and destination IP. Use Show EtherChannel Load Balance to check the current settings. For non-IP frames, the switch falls back to MAC address parameters. Think of EtherChannel like a highway. Adding more lanes increases total capacity, which is bandwidth. But the speed limit stays the same. Adding more links does not increase the maximum speed of any single communication. Layer 3 Ether channels use routed ports instead of switch ports. You configure no switch port on the member ports before adding them to the Ether channel. Then set the IP address on the port channel interface, not on the individual member ports. Layer 3 Ether channels can use PAGP, LACP, or static mode. They do not pose a loop risk, since routed ports are not subject to STP. In Show Ether Channel Summary, a Layer 3 Ether channel shows the R flag instead of S. R stands for routed port. Ether channel combines physical links into one logical link, keeping them all active without creating loops. Dynamic Ether channel with PAGP or LACP is the recommended approach. PAGP uses desirable and auto modes, while LACP uses active and passive. LACP is the choice for non-Cisco switches. Static Ether channel uses mode on with no negotiation. Port settings must match across all member ports. Load balancing distributes flows across links, increasing total bandwidth without increasing individual flow speed. Layer 3 Ether channels use routed ports with IP addresses on the port channel interface.